Okay, so for POSTLAB for the Aqueous Ions Lab, this is already posted as a reference, so you can see the entire results of the lab. And the reason we do this on this lab is because when we go to the solubility rules, if you don't have the right data, you can't actually POSTLAB correctly. Okay, so I'm going to do one from each set like I did in class. Okay, so we number half of them because these are just mirror images of each other. This one's the same as this one. So we're only ever doing half of the set. So in set one, you have 4 precipitates, and you'll see that you have 4 boxes on your data table, okay? So each one of these, you're gonna be looking at what ions were present in those drops, what possible compounds could be formed, and then we're gonna analyze this with our solubility chart, and finally write the equation for what caused the cloudiness or the precipitate. Okay, so on the first one, I'm going to do this one right here. Okay, so what I'm going to do is I am going to look at my chemicals, chemical number 1, because it's column number 1, and chemical number 3. So if I was doing number 2, it would be chemical number 1 and chemical 1, 2, 3, 4, 5, number 5. Okay, so for number 3, 1 and 3. Okay, so I'm going to look at the front side, and I'm looking at chemical number 1 and chemical number 3. When I write my ions, I'm looking at just the individual cation and anion there. So it's a barium ion and a chlorine ion. Notice I did not bring that 2 over here. That is just a balancing 2. Sometimes that's confusing for students, but anything that we've added to get the compound to be 0 doesn't transfer over to their cation or their anion symbols. Okay, so potassium is just potassium ion by itself. The CrO4 looks like the CrO4 on the chart. Okay, so when we're looking at a polyatomic ion chart, let me get that, and we look up our chromate, which is right here, we see that that 4 is part of the formula. So that's why I keep it when I write it as an ion. It's part of the formula, so I'm not going to drop that. Okay, so under here, I'm just going to ions present, transfer these guys over. So I have barium ions, and I have chlorine ions, and then I have potassium ions, and I have chromate ions. Okay, so possible compounds are like what could be happening in that drop, in those drops. So we never put the 2 pluses together, and we never put the minuses together. We're always looking kind of opposite. We're not going to put these guys together because they were in the dropper bottle and they were aqueous. Okay, so it's always kind of crossing over. We always write the metal first. So this is a +2, -2, so it's going to be barium, like that. And notice I drop those ion charges. They don't go in there. The K and the Cl, so KCl. So now from here, I'm going to look up these guys on the chart. Okay, so this is the chart in your textbook. It's on page 920. And you'll notice it's got lots of S's in the way and lots of P's and I's. Okay, so we're looking for the I. If we look at, these are the metals that are listed here. And then, so this would be the positive charges, the cations, and then the anions are over here. Okay, so I made a copy of that. So, and I did load this in eCadence, so this is in there. So let's say I'm looking at barium right here, and I go to where the chromate is, which is right here, and I see I have an I here. Okay, so that's a good suspect for being the precipitate, because I means insoluble. That's really what I'm looking for. I'm looking for the I. And that means it's insoluble or a precipitate. Okay, now just to double check, let's look and see the KCl. Okay, so when you look at K, or potassium, you can see all the way across it's soluble, which means it never forms a precipitate. Okay, but just for fun, okay, this is the chloride is right here as an S. Okay, so that means that I know for sure that it's not this one. It's got to be this one. Okay, so then when I write my equation, I'm just putting these 2 ions in together to form this precipitate. So barium plus the chromate produces the barium chromate. Okay, now when we were balancing equations, we did see different descriptors about what kind of phase of matter they are, okay? So we say that this is a solid because that's the cloudiness, that's what was formed. This does not mean the soluble, it's not that S. And then these guys were aqueous because this is aqueous. And that means dissolved in water, which all of our solutions were when we started, okay? All right, so let's do another one. Set 2, I'm gonna do number 1. So that's chemical number 1, 2, 3, 4, and chemical number 4. Okay, so 1 is strontium and nitrates. Same thing, the NO3 from the chart. I'm just gonna follow whatever the formula says. And then aluminum sulfate, same thing, I dropped that 2 for aluminum, but I'm gonna keep the whole formula for the sulfate. Okay, so I'm gonna write these down here. Strontium, nitrate, and then aluminum sulfate. Okay, possible compounds, opposites. So Sr, SO4, aluminum's a +3 and nitrate's a -1. And again, this is good practice for writing our formulas. Okay, so now I'm gonna go to the chart. I'm gonna look up these guys. So strontium is right here, and my sulfate is right here, comes to a P. So the P on this chart says partially soluble, but we will see a little bit. Sometimes when people are doing their lab, like, it's a little bit cloudy. It's not quite as cloudy as some of the other ones, and that's why it's a P, but still that's a pretty good suspect for causing the precipitate. And then aluminum and nitrate. Okay, so let's see, aluminum nitrate, that's an S, so I know it's not that one. Okay, so this has to be this guy. So strontium ions plus the sulfate ions produces strontium sulfate. That's a solid, and these guys are aqueous. All right, so moving on to set 3. Now in set 3, we have some weird things going on. It's the only set where we don't have, we have some variable metals in here. We don't have them in the other one, so you should have some Roman numerals in your names over here in set 3, not in set 1 and set 2. And then there's something in here, we have cobalt here, which actually is not on the chart. So I'm gonna do one of the ones with cobalt, just to kind of show you what I'm talking about. So that is going to be chemical number 4. So I'm gonna do the one I have numbered 3 here. So I did 1, 2, 3, 4. So this number 3 is the one I'm gonna do. So that's chemical 1 and chemical 4. Okay, so on set 3, number 3 is gonna be chemical 1 and 4. So chemical 1 is potassium and the hydroxides. And number 4 is cobalt and then the nitrates. Now I can't really look up cobalt from the periodic table, but I know it's bonded to 2 nitrates, so that means it's got to be a +2 because that compound I know is neutral. Okay, so these are going to be the ones that I'm going to write. Potassiums and hydroxides. And cobalt is +2, and it doesn't change its charge once I know the charge, okay? So then the possible compounds, KNO3, and then cobalt. This is a -1, so this is a very common mistake to go like that. It doesn't look that weird, and so people forget that you need parentheses, because I really want 2 OHs, not just 2 H's. Okay, so now I'm gonna go to the chart. And when, like we looked at before, potassium never forms precipitates. Okay, but I know this is written cobalt here, but we don't really have cobalt in our chart. Okay, so we're gonna do a process of elimination here. I know it's not that, so something's cloudy, it's gonna have to be that. So we only have 2 things we're looking at. So in that case, we can do process of elimination with cobalt and say that my cobalt ions plus my hydroxide ions form my compound. Okay, this is my solid, but notice I have a 2 here. So in order to balance my equation, I'm going to put a 2 here. Not down here, because they actually are separate from each other. They're 2 hydroxides in solution that combine with a cobalt. There you go. That's how you do that one.